reviewing your models, engineers will often perform visual checks of geometry or loads to find out if there are errors in their model. And this is an easy task when the model is small or has simple geometry, right? Those single member portal frames that some of you said you do, but it gets a little more complex when you get into the mid-size, large, and huge ones. So for years, GT STRUDL has given engineers a way to find duplicated or interference joints. Now you can also check for interfering or overlapping members. So in this example, you can see that members 1 and 2 overlap between joints 2 and 3. Easy enough to spot in a simple example like this, but not so much if this is part of a really large or complex model. So you can now generate the report from GT STRUDL calling out the members and joints that overlap, making it much easier for you to start making corrections to your model if there were errors. Also, you can now set the number or the desired number of decimal places to use when you're annotating either dimensions or coordinates in your model, which is important when the units you're using may not be easy to understand if there are only 2 decimal points. Previously, the precision was fixed at 2. Now you have the ability as the engineer when you're annotating to say, hey, give me, as many decimal places as I want. Another area that's often complex for engineers is finite element analysis, right? It's tough as it's a mixture of physics, art, and frustration to get it done successfully. Well, engineers can now leverage a familiar Excel type interface we call data sheets to create and edit element data or even create groups of elements, which enables you to organize your FEA models and greatly improves the ease of use when working with FEA elements. There's also a new finite element integrity check added to the consistency phase of stiffness matrix calculations. You can see the checks here, and this will give the engineer details as to where to start fixing any errors that may be present in the FEA model. Again, just making it easier to work with those finite elements. You'll also find a new ability to refine your FEA mesh without having to delete it and start over from scratch, which is important because the size of the mesh can affect your results, right? If you've got too coarse of a mesh, your results may be thrown off a little bit. And of course, if you go too fine, it may take a long time to run that analysis depending on the size of your model. So here you can easily just refine it as you're going through the process. For combined models with both beams and elements, when placing beams, you now have the option to split the beam at the element interference joints, allowing you to quickly glue those elements to the beam to transfer loads through that common joint. So this is especially useful when you're considering monolithic beam slab action as an example. And if you've not split the beams when you placed them, you can actually go back and choose to split the members after the fact. And you'll have the opportunity to review the split and accept or reject it. This workflow will help maintain those existing physical member definitions to keep interoperability with your designers or detailers working well, right? The last thing you want to do is send a bunch of analytical members to the CAD operator and have him have a fit that, his model's now broken.